Now next is differentiation of infinite series. Now, so let y is equal to x raised to power x and so on up to infinity, and we have to find dy over dx here, x raised to power x and so on up to infinity. Now if you see here, can I replace this? If I hold this x, what will be x raised to power x? Isn't it y? So that is, it becomes y is equal to x raised to power y. Now variable is per variable or function is per function, so taking log on both the sides. So basically again it is a part of your logarithmic differentiation. So taking log on both the sides, so we have log of y is equal to log of x raised to power y, which is your y log of x. So 1 over y into d over dx of y is equal to y into 1 over x plus log x into dy over dx. That is, here differentiating with respect to x on both the sides. Now 1 over y dy over dx minus log x into dy over dx, this is equal to y over x. If I take dy over dx common, it is 1 over y minus log x is equal to y over x, or dy over dx into 1 minus y log x upon y is equal to y over x. So you can see here dy over dx is equal to y square upon x into 1 minus y log x. So this is the differential of this function with respect to x here. Now next is, if y is equal to under root of sin x plus under root of sin x plus under root of sin x and so on up to infinity, then prove that dy over dx is equal to, this is cos x upon 2y minus 1. So the terms are going till infinity. This whole is equal to y. Again you can see here, can I write this as sin x, because root sin x plus root of sin x plus so on is equal to y. That means this is equal to under root of sin x plus y. Now squaring both sides. So what do we have? Y square is equal to sin x plus y. Now differentiating with respect to x, we have, that is, d over dx of y square is equal to d over dx of sin x plus d over dx of y. That is 2y dy over dx is equal to cos x plus dy over dx. Combine these two terms by taking dy over dx common. 2y minus 1 is equal to cos x. So what is dy over dx? It is cos x upon 2y minus 1. So that was the result to be proved here, right? Similarly, say the next one is, if y is equal to a raised to power x, a raised to power x, a raised to power x, so on till infinity, then prove that dy over dx is equal to, this is y square log of y upon, this is x into 1 minus y log y into log of x. So now this is the result which is required to be proved here. Now from here, from first, can I write down y as a raised per x raised per y? Because a raised per x raised per a raised per x and so on is y. That is why it is a raised per x raised per y. So taking log on both the sides, it is log of a raised per x raised per y, log of m raised per n. Can I write this as x raised per y log of a? Still variable raised per variable form is not removed. So again taking log on both the sides. So what do we have? That is your log of y is equal to log of x raised per y into log of a, log mn. So this is log of x raised per y plus log of a log of m raised per n. So what is that? It is y log x plus log of a. So differentiating with respect to x on both the sides, you can see here we have d over dx of log y is equal to d over dx of y log x plus it is d over dx of log of a. So what do we have now from here? You can see that so it is 1 over log y into d over dx of log y is equal to first function into the differential of second function plus second function into the differential of first plus 0, because the derivative of constant is equal to 0. So what is that? It is 1 over log y into 1 over y into dy over dx. This is your y over x plus log x into dy over dx. Now combine the terms containing dy over dx. That means we need to combine these two terms. So when you shift this to the left hand side, and after that if I take dy over dx common, it will be 1 over y log y minus log of x is equal to y over x. If we simplify this, it is dy over dx into 1 minus y log of y into log of x upon y log of y is equal to y upon x. So you can see here, if you cross multiply the terms, it will be y square log of y upon x into 1 minus y log y into log of x. So what was required to be proved? Y square log y upon x into 1 minus y log y into log of x. Again, if you are, so the stress should be on the basics. If your basics are strong, you are going to perform well in any of the exams relating to, that is your mathematics. You are not going to falter, you will definitely do well, provided that if your basics are strong. Now next is if y is equal to x plus 1 over x plus 1 over x plus 1 over x and so on up to infinity, then prove that dy over dx is equal to, it is y upon, that is your 2y minus x. This is what we have to prove here. Now from here, can I write down y as x plus 1 over y? Because x plus 1 over x plus 1 over x and so on is up to infinity is y. That means this I can replace whole this with y, that is your 1 x plus 1 over y. It is xy plus 1 over y, or y square is equal to xy plus 1. Now differentiating with respect to x, we have 2y dy over dx is equal to first function into the differential of second plus second function into differential of first plus 0. So if I take dy over dx common, it is 2y minus x is equal to y, or you can see here dy over dx is equal to y over 2y minus x. This is the required result here. So these are the questions which are based on your, you can say that is your differentiation of infinite series. Now next is parametric differentiation. Parametric differentiation. What do you mean by that? So for example, some curves sometimes are written in terms of the parameter, some functions are written in terms of the parameter. So how to differentiate them? They are not the constants, they are the parameters. They can take also any value within their domain. So what do you mean by this? For example, we have x is equal to 80 square, y is equal to 280. Now if you know that it is the representation of the parabola, it is the parametric representation of the parabola, where t can take any value over whole of the real line. Now your x is in terms of t, y is also in terms of t, then how to get dy over dx? Now dy over dx can be written as it is dy over dt upon dx over dt here. So since x and y both are in terms of t, we will also differentiate x as well as y with respect to t. So what is that? It is d over dt of 280 upon d over dt of 80 square. What is that? Is it 2a upon 280? So what is the answer? This is your 1 over d. For example, x is your a cos theta, y is your a sin theta. You must be knowing that it is the parametric representation of a circle with center at the origin. Theta is parameter, it can take any value over whole of the real line, or as a matter of fact any value over say that is your any of the quadrants here. So what do we have? Dx over d theta. Can I straightway write this as minus a sin theta? So dy over d theta. Can this be written as a cos theta? So what will be dy over dx? It will be dy over d theta upon dx over d theta, which is your a cos theta upon minus a sin theta, which is your minus cot theta. So now we will discuss more of the questions which are based on your parametric differentiation. For example, this is your question. We are given x is equal to a into cos t plus log of half log of tan square t by 2, and y is equal to a sin t. Now we have to find dy over dx. Now let me confirm the statement. X is equal to a into cos t plus half of log of tan square t by 2. So first of all we will find d over dt of x, which is your d over dt of a into cos t plus half of log of tan square t by 2. So can I write this as a into d over dt of cos t plus half of d over dt of log of tan square t by 2. So first apply the basic principle to differentiate this. Now it is a into differential of cos t is minus sin t plus half of differential of log is 1 over tan square t by 2 into differential of tan square t by 2. Now can I write this as a into this is minus sin t plus half of 1 over tan square t by 2 differential of tan square t by 2. Can I write this as d over dt of tan t by 2 whole square? So this can be written as a into minus sin t plus 1 over 2 tan square t by 2 into 2 times it is tan t by 2 into differential of tan of t by 2. So what is that? You can see here, this is, these two terms will cancel So it is a into minus sine t plus differential of tan t by 2. It is secant square t by 2. Okay, one of the factors will cancel from here. Into what is that? 1 by 2 upon, that is your tan t by 2. By mistake I have cancelled these two, whereas 1 power of this will cancel, 2 will cancel. So 1 over tan t by 2, differential of tan t by 2 is secant square t by 2 into half. Now, can I write this as a into minus sine t plus 1 over 2 times sine t by 2 upon cos t by 2 into cos square t by 2. So what is that? So you can see here, this is your a into minus sine t plus 1 over 2 sine t by 2 into cos of t by 2. So merely trigonometry is involved here. A into minus sine t plus 1 over sine t, which is your a into 1 minus sine square t upon sine t. What is that? It is a into cos square t upon sine t. This is your first here. Now from here, y is equal to a sine t. What is dy over dt? It is a cos t. So from first and second, dy over dx is equal to dy over dt upon dx over dt. That is your a cos t upon a cos square t into sine t, which is your tan of t here. Although it seems to be a complicated function, but when you differentiate it, it comes out to be a very small value, right? So this way you can get the differential of the parametric functions here. Now another example of this is, say it is x is equal to a secant cube theta, y is equal to a tan cube theta. Find dy upon dx at theta is equal to pi by 3. So we have to find the value of differential of this parametric function at the point theta equals to pi by 3. So dx over d theta is equal to d over d theta of a secant cube theta. So can I write this as a into d over d theta of secant theta whole cube? This is a into 3 times secant theta square into d over d theta of, that is your secant theta. So it is 3a secant square theta into secant theta into tan theta. Now from here, this is your first one. So y is equal to a tan cube theta. So what is dy over d theta? It is a into d over d theta of tan theta whole cube. So this can be written as a into 3 times tan square theta into d over d theta of tan theta. What is that? It is 3a tan square theta into secant square theta. So from first and second, dy over dx is equal to dy over d theta upon dx over d theta. What is that? 3a tan square theta secant square theta upon 3a, what is that? It is secant cube theta into tan theta. You can see here, this will cancel, this will cancel, this will cancel. So what is that? It is tan theta over secant theta. What is that? It is simply sine theta. So at theta equals to pi by 3, dy over dx is equal to, that is your sine 60, which is your root 3 by 2. So this is the value of the function or the differential of this function at theta equals to pi by 3. Now next is, if x is equal to a raised to power cos inverse of t and its root, y is equal to a raised to power sin inverse of t and its root, it is x is equal to a raised to power sin inverse of t and y is equal to a raised to power cos inverse of t and its root, where t belongs to -1 to 1, then what do we have to prove here is that dy over dx is equal to minus y over x. Now from here, can I say that x square is equal to a raised to power sin inverse of t and y square is equal to a raised to power cos inverse of t? So d over dt of x square is equal to a raised to power sin inverse of t into log of a to the base e into d over dt of sin inverse of t. What is that? It is a raised to power sin inverse of t, and here it is 2x dx over dt into log of a to the base e into -1 over under root of 1 minus x square. Now, can I replace a raised to power sin inverse of t with x square, which means that it is x square log of a to the base e into -1 over under root of 1 minus x square. So that means dx over dt is 1 over 2 log of a to the base e into -1 over under root of, differential, sorry for the mistake, differential of sin inverse of t is positive here, 1 over under root of 1 minus, it is not x square, it is t square. So let me check all these steps, or let me do all these steps again. D over dt of x square is d over dt of, that is your a raised to power sin inverse of t. It is 2x dx over dt is equal to a raised to power sin inverse of t into log of a to the base e into d over dt of sin inverse of t. It is a raised to power sin inverse of t into log of a to the base e into 1 over under root of 1 minus t square. I can replace a raised to power sin inverse of t with x square log of a to the base e into 1 over under root of 1 minus t square. Here it is 2x dx over dt. This will cancel. So this implies dx over dt is equal to 1 over 2 x log of a to the base e into 1 over under root of 1 minus t square. Now similarly from here, y square is equal to a raised to power cos inverse of t. D over dt of y square is equal to d over dt of a raised to power cos inverse of t. It is 2y dy over dt is equal to a raised to power cos inverse of t into log of a to the base e into d over dt of, that is your cos inverse of t. So a raised to power cos inverse of t can be replaced with y square. It is log of a to the base e into -1 upon under root of 1 minus t square. So from here the value of dy over dt is, because one of the factors will cancel from here, it's half of y log of a to the base e into -1 over under root of 1 minus t square. Question is to find dy over dx, which is your dy over dt upon dx over dt. The value of dy over dt is minus 1 by 2 y log of a to the base e 1 over under root of 1 minus t square upon 1 by 2x log of a to the base e into 1 over under root of 1 minus t square. This will cancel, this will cancel, this will cancel. So it comes out to be equal to, that is minus y over x here. So this way we can find the differentiation of the parametric functions here. Now another is, for example, x is equal to 2 cos theta minus cos of 2 theta, and y is equal to 2 sin theta minus sin 2 theta, and what we have to prove here is dy over dx is equal to tan of 3 theta by 2. So this is what we have to prove here. So very straightforward question, dx over d theta is d over d theta of, this is 2 cos theta minus cos 2 theta. This is equal to minus 2 sin theta plus sin 2 theta into 2, which is your 2 times sin 2 theta minus sin theta. So can I write this as 2 times sin c minus sin d is 2 cos c plus d by 2 into sin of c minus d by 2. So whenever the function is of the form sin c minus sin d, applying the CD formula here. Now next is y is equal to 2 sin theta minus sin 2 theta. Now can I write this as dy over d theta equals to 2 cos theta minus 2 cos 2 theta. So this is equal to 2 times, it is cos theta minus cos of 2 theta. Again you applying the CD formula. Cos c minus cos d is minus 2 sin c plus d by 2 into sin of c minus d by 2. Because sin of minus theta is equal to minus sin theta, it becomes 4 sin 3 theta by 2 into sin of theta by 2. So that was your dy over d theta. So what is dy over dx? It is dy over d theta upon dx over d theta. What is that? 4 sin 3 theta by 2 sin theta by 2 upon 4 cos 3 theta by 2 into sin of theta by 2. So which is your tan of 3 theta by 2. Right? Now next is, if x is equal to sin cube t upon under root of cos 2t and y is equal to cos cube t upon under root of sin 2t, then what do we have to prove here is dy over dx is equal to minus cot of 3t. So this is what is required to be proved here. So dx over dt is equal to under root of cos 2t into 3 sin square t into cos t minus sin cube t into 1 over 2 times under root of cos 2t into minus sin 2t into 2 upon, what is that? It is cos 2t. This term will cancel. So if you take the LCM, it is 3 sin square t cos 2t cos t plus sin cube t into sin 2t upon cos 2t into under root of cos 2t. So here I have the differential of that is your x with respect to y. Similarly, I am straightway going to find the differential of y with respect to t, and hopefully all of you can understand how I have done the differential. I am using u upon v rule here. So under root of sin 2t into 3 cos square t into minus sin t minus cos cube t into 1 over, okay. So here again it is, that is your cos of 2t here. So let me find the differential of y with respect to t again. So this is equal to under root of cos 2t into 3 cos square t into minus sin t minus cos cube t into 1 over 2 times under root of cos 2t into minus sin 2t into 2 upon, what is that? It is cos of 2t here. So what do we have? It is minus 3 under root of cos 2t cos. So just go through all these steps. You can see here it is that is when you take the LCM here, it is with the negative sign minus 3 under root cos 2t cos square t sin t, minus into minus plus cos cube t into sin 2t. Now upon under root of cos 2t upon cos 2t, take the LCM and you will get this term. Now dy over dx is equal to dy over dt over dx over dt. This is your, so when you simplify this, you can see that using the formula, that is sin 2t is equal to 2 sin t into cos t. Using the formula here, now it is sin t into 3 times cos 2t, 1 minus 2 sin square t plus 2 sin square t. So this can be written as cos t into minus 6 cos square t plus 3 plus 2 cos square t upon sin t into 3 minus 6 sin square t plus it is 2 sin square t. You can see here it is cos t into minus 4 cos square t plus 3 upon sin t into 3 minus 4 sin square t. Can this be written as minus 4 cos cube t plus 3 cos t upon 3 sin t minus 4 sin cube t? So if I take negative sign common from here, it is minus 4 cos cube t minus 3 cos t upon, what is that, sin 3t, that is your minus cos 3t upon sin 3t, which is your minus cot of 3t here. Bit lengthy question. Well, it was not difficult to solve, but you should be very careful about all these steps. Be careful so that you don't commit any mistake. You can see that this is your minus of cot 3t here.